Hi, so I apologize for the quality on this answer key. I don't know why I picked an orange pen to write my answers, but I'm too lazy to write them all again. So I'm just going to read them out, and I think you can read most of it. You should be I'll mark the answers and give them back to you, so it shouldn't be a problem. I'm just going to go over the major types of light again, just because some people in class were having doubts about what each one was. So there's a couple of different categories that I want you to remember. So first you have your incandescence, which is basically something that produces IR radiation. So in a light bulb, it's a tungsten filament. So we saw in our ray box there was a tungsten. If you looked at the light closely, there was a tungsten filament there, which electricity is passed through. It gets heated up and gives off a lot of infrared radiation and a little bit of visible light radiation, which we see as light. Number two, this was the fluorescent lamp, and you could tell because it was a very white light, and you could not see inside the bulb. It's like a kind of foggy kind of substance, and that's because how it works is there's mercury inside there, which produces UV radiation due to electricity being passed through it. That UV radiation is then absorbed by a fluorescent substance. So UV light is produced inside the bulb by mercury, which causes the fluorescent substance to absorb them, as in the UV rays, and release visible light. So that's the definition of fluorescence, and that was a fluorescent lamp. A third one was a picture on the PowerPoint. It was neon lights. We had to know about electric discharge, which is when electric current is passed through a non-reactive gas like neon or krypton, something like that. Okay, moving on, since we've already covered most of this. The candle is also incandescence. Glow stick was glowing bright green. Chemiluminescence, light produced by a chemical reaction which occurred when the glow stick was cracked. Okay, this is actually really bad quality. I'm gonna re-upload this picture, but we're gonna continue this anyway. So chemiluminescence is a light produced by a chemical reaction, which is like the glow stick. Glow-in-the-dark pajamas and the little star things that we saw, which were glowing bright green. This was phosphorescence, and because those stars were old, I guess it wasn't as easy to see the difference between fluorescence and phosphorescence. Phosphorescence is the same as fluorescence, right? You shone a UV light using the black light on the stars, and they glowed like a fluorescent colored green, except those stars and the pajamas glow for a longer period of time. So they release that energy as visible light slowly, which is not like fluorescence, which releases it all at once. So again, fluorescence, like the lamp that we saw in number 2, release the energy all at once. Phosphorescence, like these glow-in-the-dark stars, releases the visible light energy slowly, and that's the difference between them. Moving on, we have a light ray box, which if you saw the filament inside, if you actually saw the bulb, there was a filament inside, which was incandescence. Magic sand, this was fluorescence because a UV light is shone on the sand, which glows fluorescent green for a very short amount of time, so it releases that visible light instantaneously or immediately after absorbing the UV rays. And that's why it's fluorescence. This one hopefully was good. Glowing fish and jellyfish was bioluminescence, which is light produced by a chemical reaction inside a living organism. The triboluminescence, not many people got. Not many people got the actual light to be produced when you rub the two quartz crystals together. That was fine. It's just light produced by friction of rubbing rocks together. And the LED lamps, we will note that there's no tungsten filament inside those lamps, and you can actually see inside. Well, it's not like the fluorescent lamps, which are like bright white, and like a opaque kind of translucent gas looks like to be filled inside of it. This was just a small Christmas light kind of thing, and we know LEDs produced by semiconductors when a voltage is applied. So that was the lab that we did. Hopefully everybody's okay with that. We will have to learn all the different kinds of all the different ways to produce light, so make sure you're good with all these types. We're going to briefly talk about the other things we covered at the end of the class. We wear lighter clothes in the summer because we know white clothes reflect. So white colors, we know that they reflect all visible light, and they also reflect IR rays. So because they reflect all these things, they keep you cool. I mean, I wouldn't say keep you cool. They make you get less hot during the summer. So in the summer, when it's already very hot, we want to wear light colored clothes so that we don't heat up anymore. And you wear darker colored clothes in the winter because it's cold and you want to heat up. You want to get as much heat as possible. So darker colored clothes absorb visible light and IR rays. So that's very good for you in the winter. We also talked about melanin. Melanin is the pigment that is produced by the skin in response to an excess of UV radiation. It's not produced instantaneously. It occurs over, I would say, generations, and natural selection then favors people who have an increased protection to UV rays, because we know UV rays, an excess exposure to UV rays can cause skin cancer. So melanin is that pigment that protects us against UV rays. Now, UV rays is like a double-edged sword. We need a little bit of it. UV rays needed for vitamin D production, but excess exposure can cause skin cancer. All right, so we need a little bit of it, but not too much. It's like, pretty much, anything. In moderation, it's good, but as soon as you get too much, it starts to get not so good. So in countries where there's a lot of sunlight exposure, a lot of UV, the hotter countries around the equator, those countries get a lot of UV rays from the sun, so that's excess UV. So the people living there have evolved to have a lot of melanin pigment in their skin, which causes them to have a darker skin tone. The people living closer to the poles, where there's not a lot of sunlight during the year, for example, we know in Canada in winter the sun goes away sunsets around 4:35, so you don't get a lot of sunlight during the day, and so we need to absorb, or people living in Canada or the countries up here need to get as much UV as possible while they can, and so they have lighter skin. So there's no melanin protecting them because there's not a lot of excess of UV rays. Whatever is there is just absorbed for the production of vitamin D, and that's about it. Just a note, this is becoming increasingly a problem because there's no ozone layer. I mean, the ozone layer is deteriorating, which we'll talk about in our climate change unit. And because of that, because the ozone layer is deteriorating, well, it's not directly due to climate change, but it's, sort of related. Because of that, the ozone layer is deteriorating, and the countries near the pole are also getting an increased concentration of UV rays, which is very bad because people who have lived here for generations don't have the necessary melanin in order to protect them against UV rays. So that's worrisome, certainly. But yeah, okay, have a good weekend. If you're watching this when I post it, which I realize you're probably not, because you will be actually having a good weekend. Anyway, I will see you in class. Peace.